In this video, I'd like to show you how to plot the data in a semilog paper. Before starting, I'd like to show you the linear paper, which is much easier to do. In a 2D plane, so the linear paper has two axes, so x-axis and the y-axis. So usually the x-axis is a horizontal one, and the y-axis is a vertical one. So we call it the linear paper because all the intervals, regardless is x-axis or the y-axis, are evenly spaced with uniform grids, right? So you can see between any two intervals, so the distance are exactly the same. For a semilog paper, usually either the x-axis or the y-axis is log scaled. For a typical PK data set, usually the y-axis is log scaled, which is usually for the concentration. The x-axis is for the time. There is a very important term for the semilog paper is called the cycle. So a cycle refers to the repeating intervals that spans tenfold range. So for example, if we start from 0.1, the tenfold will be 1, right? So from 0.1 to 1 is one cycle. 1 to 10 is another cycle. 10 to 100 is another cycle. And another one, for example, 100 to 1000, right? So this is a typical two-cycle semilog paper. So 1, 2. So if you can cut in the middle, you can see the top one and bottom one can be overlapping, right? And of course, this is a typical 3-cycle. You can have more, like 4 or 5. It really depends the data you have. So the next thing we have to know is how to label the y-axis. So for the cycle, we have start with 1, right? Either from 0.1, 1, or 10, or 100. It really depends the data you have. So let's make it easier. Let's start with 1. So this is 1, 2, 3, 4, all the way to 10. So that's very important for the next cycle. For the next cycle, the units or the steps is the smallest number of that cycle. So that means for this cycle, this is 10, this will be 20. It's not 12 or something. So 30, 40, 50, 60, 70, 80, and 90. And of course, this is 100, right? So if you keep going, there will be 200, 300, all the way to 1000, right? Of course, you can also start with 0.1. Okay, it's fine. So 0.1, that means this will be 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Then this is no longer 10, it's 1. Okay. Then of course this will be 1, this will be 2, 3, all the way to 10, right? So this is how to label the log scale. And for the linear one, it's much easier. So basically you can do like this is 1, 0, 1, 2 for each grid is for 1 hour. You can all the way to 10, right? So for example, something like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But if you plot the data in this labeling in this scale, so you will see all the data sets pretty much will be towards to the left-hand side, right? Then the right-hand side will be pretty empty, right? So I mean, it won't look good, right? So instead we only do like the 1 grid for each 1 hour. Then of course we can do more, right? We can do 2 grids for 1 hour, right? This is 1 hour, this 2 hour, right? And this 3 hour, right? So it looks something like this, right? 0, 1, 2, 3, 4, all the way to 12. Now, if you plot the data, then this curve will definitely look much more balanced, right? Okay, so when we start to plot the data, so the first thing we have to figure out is how many cycles we have to use. To determine the cycles we have to use, so it's not so hard, so it's easy. So let's take a look at the concentration over here. So the first one, we figure out what is a minimum concentration or the smallest number. So it's 1.8, right? So 1.8 is between 1 to 10, right? And also the maximum number is 70, right? 70, that's between the 10 to 100, right? So therefore, you can see 2 cycle will be sufficient, right? So 1 to 10 and 10 to 100, right? 2 cycles will be enough to cover all the data sets, right? So now we can start to plot the data. So first one is 1 hour 70, right? So 1 hour is 2 grids or 2 subunits. So over here, and the 70 is right over here, right? So 1 hour 70. So the first one is easy. So the next one is 2 hour and the 38, right? So let's magnify this. Let's zoom in a little bit. 2 hour 38. So this is 1 hour, this is 2 hour, right? 38. That means between 30 to 40, right? So here we can see from 30 to 40, we have 10 units, right? And also we have how many grids in the between. So 1, 2, 3, 4, if you count, would be 10. So 10 by 10 is 1. So that means each subunit represents 1 unit. So 30, 31, 32, 33, 34, 35, 36, 37, and 38. Of course, you can count from the top, which is faster, right? 40, 39, 38, right? So this is the second one. So the next one is 1 hour and 15, right? So this 2 hour, 3 hour, 4 hour, right? 15. So 15 is between 10 to 20, right? So again, 10 to 20 is 10 units. So we have how many grids in the between? So we have 5, 10, 15, and 20, right? So we total have 20 subunits. So that means each one represents 0.5, right? So here is 8 hour, and this, so this is 10, this will be 10.5, right? And this is 11, right? And 11.5, 12, right? And the 13, 14, and 15 is right over here. So of course, that's an easy way to do this because it's 15 is right in the middle of 10 to 20, right? And we do have like a little bit of a thicker line over here, which represents a quarter, right? So this is a quarter, this is half, right? And the 3/4 and the whole, right? So that means half is right over here. So we don't really need to count each subunits. So that's 4 hour. So the next one would be 8 hour 5.5. So 8 hour is here, and the 5.5 is between 5 to 6, right? So between 5 and 6 is 1 unit, and we have 1, 2, 3, 4, 5, right? 5. So equals 0.2, right? So over here, so 8 hours, so here, so 5, 5.2, 5.4, right? This 9 will be 5.4, and the top one will be 5.6, right? So 5.5, of course, is right in the middle, right? Okay, 5.5. So the last one is 12 hour, 1.8. So 12 hour is over here, and 1.8 is between 1 to 2, right? So here, very important. For the y-axis, it start with 1, right? It's not 0. So 1 to 2 is 1 unit, and then we have 20 grids, right? Same thing, right? 20 over here. So that gives you 0.05. Okay, so this is so this one is 1.05, right? If you keep going, this one will be 1.1, right? And 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, right? For this night, right? And of course, this is 12 hours. So right over here. Okay. So now let's see. So here is all the data we have. So now we finish plotting.